All right, so today we're going to finish up section 5.5, dealing with performing function operations. And actually, the only bit of new information that we're going to add today is this idea of evaluating these functions for a given value of x. All right, so a lot of today is going to be very similar, and now we're including this idea of evaluating for x equals -1 or whatever that value of x is going to be. So take a moment, pause the video to write this down if you need, but I'm going to jump right in. And just like yesterday, I'm going to do my f plus g of x in red and my f minus g of x in blue, so we see the difference between those two problems. So f plus g of x equals f of x, -x squared minus 3x plus 8, plus g of x, 6x minus 3x squared. All right, so that has me adding those two together. When we're adding, the parentheses aren't doing anything, so they can just be dropped, and I can combine like terms. So this equals -x squared minus 3x squared becomes a -4x squared. -3x plus 6x becomes a 3x plus 8. All right. So that's the answer for f plus g of x. Now, the next step for today is to evaluate for x equals -1. So we're going to find what f plus g of -1 is. This means that I take -1 and I plug it into this function. So -4 times -1 squared plus 3 times -1 plus 8. Gives me -4, -1 squared is 1, times 1 stays as -4, plus 3 times -1 is a -3, plus 8. -4 minus 3 is a -7, plus 8 is a +1. So once I add them together, I can evaluate the function f plus g of -1 is +1. Next, I have f minus g of x equals -x squared minus 3x plus 8 minus 6x minus 3x squared. Same process, but I'm subtracting. Like we remember in the past, when we subtract, we really add the opposites. So now I get -x squared plus 3x squared becomes 2x squared. -3x minus 6x becomes -9x plus 8 as my answer. And again, we can find f minus g of x this time. F minus g of -1 equals 2 times -1 squared minus 9 times -1 plus 8. -1 squared is 1, times 2 is 2. -9 times -1 is 9. So I get 2 plus 9 plus 8. 2 plus 9 is 11, plus 8 is 19. So the answer for f minus g of -1 is 19. Now, we're going to do one more problem. And just like the pattern we've been doing, now we're going to do a different problem that involves f times g of x and f divided by g of x. And the only addition for today is that we're going to evaluate for x equals 4. So we're going to do f times g in red, f divided by g in blue. F times g of x becomes 12x times 11x to the 1/2 power. This is already as a fractional exponent, which is great. All right, it means I don't have to do any changing there, which is awesome for this initial part. All right, so I get 12 times 11, which is 132. I need to add these exponents. So I get 132 times x to the 1 plus 1/2 is 3/2 power. 1 plus 1/2 is 2/2 plus 1/2, which is 3/2. So that's how I got that exponent. So that's my answer for f times g of x. Now we need to find f times g of 4 equals 132 times 4 to the 3/2 power. Now, in this case, the fractional exponent actually creates more of an issue. Okay, I could in my calculator find what 4 to the 3/2 power is, but just to solidify some of our math, that equals 132 times, this becomes the square root of 4 cubed. Remembering our rule for changing fractional exponents to rational expressions. Gives me 132 times 2 cubed, which equals 132 times 8, which is going to be a big number, which is 1056. So our answer for f times g of 4 is 1056. Last part we're going to do in blue. F over g of x equals 12x over 11x to the 1/2 power. Which equals, we're going to have 12 over 11, and 1 minus 1/2 is 1/2. So I've got 12 over 11. We're going to put the x to the 1/2 power on top. We could have 12 over 11 as its own fraction, but I'm going to leave it like that. Now we need to find f times g of 4. I'm sorry, f over g of 4, I apologize. So I'm going to plug 4 in for this. So 12 times 4 to the 1/2 power over 11 equals 12 times the square root of 4 over 11. Fortunately, you were given a nice perfect square. That equals 12 times 2 over 11, which is 24 over 11, which is our answer. So again, really the only thing new today is being able to evaluate these for a given value.